Hi everyone and welcome to Activity 15. Today we are going to start on page 199 and talk about our periodic functions. Now, before we get started too much into the different pieces of our periodic functions, we have a situation talking about Stacy and her new bike. And with Stacy and her bike, she has a 24-inch diameter front wheel. So that's going to be these big ones versus a 6-inch diameter training wheel on the back of her bike. We talk about this horizontal distance between the two of them being 24 inches. And again, that distance between, and we have different times it takes each wheel to spin around. The 24-inch wheel is going to rotate once every 4 seconds versus the training wheels that are going to move a little bit quicker around. So if we talk about kind of the situation here of our bikes, again, if this is a 24-inch diameter, then each piece from the center is 12 inches versus each of these that would have a 3-inch diameter. Again, there are 36 inches in between these two. And again, we talk about that big wheel having that certain diameter. So if we look at a graph of this situation on the next page here. All right, we have, again, it taking 1, 2, 3, 4 seconds for that big wheel to transform. And if we make our scale go up by 3, 6, 9, 12, 15, 18, 21, 24, we can see all the way to the top that if we run over a paint speck on the ground, throughout this graph, it'll go up, it'll be 24 inches across the ground, and by the time it gets down to 4 seconds, it'll be back on the ground. And then same thing would happen 5, 6, 7, 8. This rotation would occur that if we were following, for instance, like I said, like a red speck on the bottom of the tire, and its transformation all the way around this, it would take, again, 4 seconds there for this initial graph of Stacy's big wheel. Now the smaller wheel is going to start a little bit behind when it starts hitting this paint speck to go through, but it rotates around every second and again gets that max off the ground of 6 inches based on its diameter. So it's going to repeat a little bit more frequently. And again, max it gets is 6 inches off the ground based on that size. Now, if we kind of move on then, right, skip to page 204, we see in 15.2 on page 204 that they are asking us to start affecting different parameters. For instance, what happens if the height of this wheel goes from being 24 inches every 4 seconds to only 18 inches, right? What would happen? Well, we said we had in this original graph, it would look something like this, right? Her wheel would be going up, down, back to the beginning, up, down, back to the beginning. Well, if we change this wheel to only be 18 inches in diameter, but still spin around the same amount of time, that's going to change here, that max peak, to only be maxing out 18 inches across the ground. On the next one, in part B, it says, okay, we're taking that 24-inch wheel, but instead of making a revolution every 4 seconds, what happens if we change it to every 3 seconds? So again, we had this original graph that looked something like this, right? We were every 4 seconds it was repeating. Well, if we change this to now being every 3 seconds instead, we're going to hit that peak a little bit quicker every 1.5 seconds. So we would shrink here, and by the time we get to 6, again, we would be back down at the bottom, which means at 4.5 seconds in, we would hit our max there. So we keep seeing that every 1.5 seconds as opposed to every 2 is when we would be hitting that max point. Now, for all of these, we decided to start our graph at 0, kind of being that bare minimum. Well, what if we retook this wheel and kind of redecided, okay, this is actually negative 12, this is 0, this is positive 12. So it still has that 24-inch wheel, however, we are choosing kind of a different starting point. Well, what would happen is our graph would be starting down below at -12. And again, if we're going still our traditional every 4 seconds that it would take to get back to the beginning, that's when it would be back down there. But halfway through, at 2 seconds, it would actually be up here at this peak of +12. So that we would have this graph here, something like this little sketch. And again, it would repeat 5, 6, 7, 8 seconds in, same kind of idea, halfway through, back down to that minimum at 8 for that sketch. So again, essentially what we did was shift this graph down 12 inches from that original starting point at 0, but everything else kind of stayed the same. The last one in number 4 says, okay, what if we shifted this over? It says that if we shifted this to be in charge of the start of the training wheel versus the start of that big graph. So basically what happened is all of these moved to the left 6/pi inches, or about 1.9 units left on that one. So we see that shift in both of the graphs. Now what this leads us to, if we finally get to page 206, is the idea that we have this periodic function, aka a function that repeats itself. Right? That's kind of another way of thinking about a periodic, is it's repeating, and it repeats itself the amount of the period for the function. So for the ones we've been dealing with, about 4 seconds, for instance, that 24-inch wheel, or 1 second for the training wheel. And there is a max and a min value in each of those. Half of that value would be called its amplitude. And then finally, a phase shift would be changing a horizontal translation left to right. And all of these vocab words, again, you will see on page 206. So now if we kind of look at them in action, right, for graph for question number 5, if we look at this graph that took us from that original 4 second to shrinking it down to only 3 seconds, what that's going to be changing on us is our period, right? So we would say that it shrunk from 4 seconds to repeat to only 3 seconds for the second one. Now graph number 2 that shrunk the overall height. We had that original height that was up at 24, and there was one of these examples that we said shrunk our wheel down to only being 18. What this one changed on us was the amplitude. And the reason being, the height shrunk down as well. Part C said which one was a vertical translation. Well, if we look back to our graph, we said that in item number 3, we shifted our graph down 12 units. So that's going to be our one that changed here. Item number 3 went down 12. And then we had a phase shift occurring in item number 4, and that's where we moved left about 1.9 units. Now, those are for some of the graphs that we were in charge of creating. We also are going to be asked to identify the amplitude and the period given a graph. So again, the amplitude, you want to check out 2 things. What is my max point? And what is my min point? In this case, we have a max at 3, a min at -3. So the total distance between these two would be 6 units. Now, when it comes to the amplitude, you're going to take that distance and divide it by 2. So again, that distance between the max and the min divided by 2 would give us our amplitude, which is going to be 3 units. So again, you can also think of that as like half that distance between the max and the min. That's your amplitude. Now, the period then is going to be based on how long does it take this graph to repeat. So for instance, max to max, or one full revolution back to your starting point, in this case at 0. Well, on this one, the period would take 10 seconds or 10 units, because that's how long it took to do one full revolution of our graph, would be 10. All right, now we will definitely work more with identifying that in class. Our last part then of this lesson is going to take us to page 208. And what we notice on page 208 is, again, this situation of the wheel where it was taking the 4 seconds to repeat, but we started at 0. So we're back at this graph with that vertical translation. And what's happening here when we have this vertical translation and this repeating nature is we start at 0, we go up, down, back to the beginning, and then that pattern continues through the rest of this graph, up, down, back to the beginning. And again, this is going off of the fact if we start at -12, go to 0, up to +12, similar to the item on the previous page, or previous section. Well, if we start changing some things around, so instead of calling these, we change this to feet, we would have 0 feet, half a foot, 1 foot. Again, this is changing this from being inches to feet. So then down below, if we converted that, that'd be negative for half an inch, or half a foot, and then -1 foot, again, if we're changing up those units from inches to feet. Now, the overall graph, though, is still going to be the same, right? You're still up at 12 inches the same way you are 1 foot. All we did was change the units. The rest of this is staying the exact same. Number 4 then asks us to change this again. This time they want us to, how many degrees would it be in the time of 8 seconds? Well, 8 seconds would be 2 rotations of our tire. So the 2 rotations of our tire going around once, twice, would be a total of 720 degrees. So in order to get to 720, each of these on our scale would go up by 180 here. And then otherwise, though, our graph is going to look very similar to what it did before. Up, down, back to the beginning, up, down, back to the beginning. Just changing our units this time, 2 degrees from seconds. And we know from our time talking about conversions, again, if we change this up yet again, we know that 180 degrees is pi radians, 360 is 2 pi, 3 pi, and 4 pi if we change the scale to be in radians. But otherwise, oops, this graph didn't change otherwise. Everything else looks the same with our rotations through. And what we're noticing finally is if we look at this graph in comparison, this is actually giving us kind of that parent function of our sine graph. So if we take our calculators and we put our mode in degrees. So you're under your calculator mode menu, and you make sure your calculator is in degrees. Oops. And we go under our graph and we change this to be sine of x. And if we zoom option 7 trig, again, what we're going to see is a little bit this graph. Now, we can adjust our window on this. If we go from 0 to 720, go up by 180, what's going to happen is our graph ends up matching, essentially, our picture. And we can also adjust this a little bit from -1 to 1. Go up by 0.5 each time, then we change the y's as well. We have the exact same graph here as before. They are the same. And we can also do this if we switch this to radian mode. What we're going to notice is as long as when we switch the modes, we change the x scale like we did before. We're going from 0 to 4 pi, going up by pi each time. We also will notice that this graph looks the exact same, right? So we see this here as well. They are the same. And again, the big deal here is that this is the parent function of sine of x. The amplitude on this graph is going to be 1 because the distance between top and bottom is 2 units. However, the actual amplitude is half of that. So 1. Period each time it takes 2 pi units to repeat itself. So the overall period of this function is 2 pi. Now we will be working a lot more with these in class, but this is then kind of connecting the idea of our parent function sine to our other periodic functions and real life situations. Thanks everyone for watching.